So, first off, let's, oh, come on. Let's do some very basic definition. Force is any time an object is interacting with its environment. So force is more than pushing or pulling on something. Force is a whole lot more than that. There are forces acting on you right now. Forces acting on you right now from far, far, far away. Mm-hmm. Force tends to cause acceleration. Oh, if I do that, I get an echo chamber. Oh, an echo chamber. That's a special effect.
This is not
This is a fun video to watch.
So, when a force interacts with an object, it often causes acceleration. What is acceleration? Define that for yourself. That is one acceleration. What is acceleration in general? Faster, faster, faster?
Yes.
Or
slower.
Or turning. Yeah. Coming down Route 7 from Rogers to here, if you maintained a constant speed of 35 miles per hour, would you accelerate?
Yeah, because you go
Through the snake curves on Route 7 between Rogers and here at a constant speed of 35 miles per hour, you most certainly, if you're not accelerating, you're in the creek. If you do not accelerate through that section of road, you will end up in the drink.
I don't know, 35?
I'm being conservative.
I mean,
Yes, you can take it faster than
I think you can
35.
make it through the snake turns at 35 constant.
Yes, you can. Joe, perfect. You made the exact right mistake.
Okay.
Yes, you can maintain a constant speed of 35 miles per hour through the snake curves.
Oh yeah, I forgot about that.
There we go. But if you don't accelerate, you're in the creek. Why? Direction. Direction. Velocity. So, if you're at a constant speed, but you turn, you have changed your velocity. Because remember, speed and velocity are separate things. We often get sloppy, and I'm guilty of this too. And we say velocity when we really mean speed. But remember that velocity is the speed and the direction. So if you maintain a constant speed through the snake curves, you are still accelerating. Because if you're not accelerating, you're off the road. If you hit the top of the snake curves and you never accelerate, actually right at that school, you'd end up right in the drink. Just below, yeah. So, splash. When you have a force acting on something, it's going to cause acceleration. Okay. The unit that we use for force is the Newton. You will become very familiar with Newtons. Named after who do you suppose? Sir Isaac. Weirdo, yes. 1 Newton is the amount of force that it takes to accelerate 1 kilogram at 1 meter per second squared. So a Newton, therefore, is 1 kilogram meter per second squared. F equals ma. Now you did learn that in physical science. If you have a science club shirt this year, you also have a nice little reminder. May the mass times acceleration be with you. This is 2 years in a row we've had physics-y science club shirt. It's pretty exciting. Was it last year or 2 years ago that we had?
It's not the final one.
It's not the final velocity that kills you. It's the change in velocity. It's the force caused by the change in velocity. Yeah, nobody gets it, but that's okay. You will after this. You will. You will understand last year's science club shirt in a whole new way. So we can look at dimensional analysis. You will never forget F equals ma. Obviously. You probably already walked in here thinking, ooh, F equals ma. I'm a mind reader. It's a gift you develop as a teacher. So since you know F equals ma, you're always going to remember that a Newton is equal to a kilogram meter per second squared. That's going to be incredibly useful when we're doing more complicated problems because you can then apply dimensional analysis to it. And boy, is that going to help you because the algebra in this chapter gets heavy. It's awesome. It's cool stuff. We move stuff around. It's good thing.
Last chapter was a little crazy.
Nah. Okay. So, two kinds of, well, wait, let me ask you a question first. Ooh, this is good. You guys don't have your notes, so I can ask you questions and you don't have the answers on a packet in front of you. A packet?
Are you from Michigan?
Packet?
Packet.
Bad. Put the keys on the
Ma'am?
table. Mom, can we go sit down? We're going to get meal. Okay.
My sister spent a week with my cousins up in Michigan. Came back down, she's calling my mom, ma'am.
Okay, so I mentioned to you that there were forces acting on you right now. Put your pencils down, put your hands on your desks. Everybody, brace yourself.
Should I like
Earth
hold on?
is
Well, yes, the Earth is moving. You are hurtling through space at an astonishing rate of speed. But let me ask you this. Don't yell this out. From whence do these forces come?
Whence?
From whence do these forces come? There are forces acting on you.
From where? Or
From whence? Yes, from where? Where are these
Gravity.
mysterious forces? You named a force. Where is it coming from? Like this part of the Earth?
No, like the Earth in general, like the planet Earth.
Oh, that's so vague.
But it's right.
Oh, young Mr. Hall seems to have an idea about this. Center of the planet. You mean the hollow spot where the lake is?
Are we gonna go to that?
The core of the Earth, yeah. I want you all to know this. This will be part of your daily affirmation. You are all attractive. You are all very attractive to the center of the Earth. You are all very attracted to the center of the Earth. The center of the Earth is attracting you right now. If the center of the Earth stopped attracting you, you would float right up into space.
And then we'd probably get sucked into something.
Well, then yeah, there's all kinds of bad things that would happen. But so let me ask you this: do you have to be in contact with the center of the Earth for it to be attracting you?
Nope.
So if you stand up on top of one of these lab tables and jump into the air,
Oh, like
the center of the Earth will still attract you?
yes.
Hence gravity, hence ouch. Okay. So,
Well, that's why you don't leave this way. Actually, go straight up.
you're telling me that this force that's acting on you, this mysterious invisible force from the center of the Earth to you, you don't have to have any contact with the Earth
That's right.
for it to happen. Okay, which brings us to, now, let me ask you this question. If I come over here and I shove Devin, which I'm not going to do, that would be mean. If I shove Devin, is some force, I'll do it. Am I acting on her? Is there a force generated by me that's acting on her? But what if I do it from over here? Okay, Devin, get ready.
You were close.
Nothing? Chris? Nothing? Okay, Hannah. Nothing? Still?
Flinched a little bit.
She flinched. Okay. There are two basic broad categories of forces. Contact forces, me shoving Devin, and field forces. Sadly, for all the years that I've been practicing, I still do not possess a field force. So a field force does not have to be in contact with something. Would gravity be a field force or a contact force? Field force. You pushing someone, we're talking about contact force now. What about friction? Contact. You have to have contact between the two objects, or there is. Yes.
That's true.
Okay. What about? So name me another field force.
Magnetism.
Oh, good. You're good. Okay. So magnetism and gravity. Name me another field force.
I mean, that's the food.
Yes.
Clever.
Hunger. Actually, electromagnetism all gets wrapped up into one. So, has anybody here ever been out in a lightning storm, being stupid, and had their hair stand up?
Nope.
Like
Hannah, you would be a good candidate for this because you golf and you have long hair
That's something.
and you have light hair.
I mean, I was involved in
Did anybody else ever say to you, Hannah, I think we should go in? Okay, so,
Saw your hair stand
electric,
up.
if you end up in a field of electrical charge, and I've had this happen, your hair starts to stand up. I'm going to give you a little piece of advice that's only marginally physics related. If you're outside with electrical activity around you, and you notice that somebody around you's hair is starting to stand up, you should go under shelter.
Tree?
Not
Their hair.
Not a lone large tree, but if there's nothing else available, being in the midst of a grove of smaller, approximately equal sized trees is your best bet. But if possible, you should just go inside. Caves are okay too.
If they're not equally like size, like the smallest one, or the biggest one.
What?
Like the trees that are all.
You want to be in a bunch of trees that are roughly even sized.
So there's really one big tree in the center. You should go.
So
No.
So what?
Okay,
What about
so
a car? Should you get your car?
you can get your car. Yeah, that's insulated.
I think I
It like is a Faraday cage, basically. We'll talk about Faraday cages later. Okay, so field forces, contact forces. This is probably about as far as we're going to get. Tell you what, copy this down. We will do.
last slide.
That's okay.
Right?
Okay.
You can print them tomorrow, yeah. Or copy them from Joe.
No.
We are going to start talking about force diagrams. You are going to get so good at force diagrams that you will probably want to go home, paper the walls of your bedroom with white butcher paper, get a set of colored markers, and go nuts.
Oh, you told me I should. I'm gonna do a lot of things I haven't done.
Well,
Like, get tattoos of
there's time.
formulas.
There's
I haven't
time.
done that yet.
There's time.
Well,
There's
it's
time.
21.
Get that periodic table brought on my back.
And you have the periodic table on your back, your 4 golden equations on your forearm.
What would be the point of periodic
Just be cool.
Does it have to be like all backwards?
Yeah, you can do that. You can do that. No. But if your friend got one and sat in front of you with a low-cut
Well, that's
hang,
good.
best
Then
friend.
they're screwed.
Well, they would have to have somebody ahead of that. I mean, it would just be a whole chain of
Someone
periodic
better
tables.
No, we would all just
Make a
sit in a
circle.
circle.
Yeah. Okay, so we're going to start talking about force diagrams. You know that force is a vector. It's just like velocity. It's got magnitude. It's got direction. And this chapter, if it's possible, gets even more visual than the last chapter. There is a picture for every single situation with lots of pretty arrows and colors and bright things. So we represent this graphically often. Okay, I'm going to stop this.